One way that this class is different from first year chemistry is the fact that instead of just accepting values that were given in a problem, we're actually going to be looking at the tools that are used in order to measure these values. And so the last thing that we talked about in the previous video was talking about different atomic masses and how those can be averaged in order to find the atomic weight of a specific element. Well, how exactly do you find the atomic mass of all of these different isotopes of an element? And how that's done is by using what's called a mass spectrometer. Now, a mass spectrometer measures the masses of individual molecules, but the way that it does that, it uses a magnet, but in order for this magnet to separate them out based on their different masses, it first ionizes them. It makes them have an electrical charge. Once these isotopes have different charges, then when they go around and are deflected by these magnets, then they can be separated out based on their different masses. And so what this shows you is that an electron beam is actually shot through the gas atoms or the gas molecules, and it makes them become positively charged ions. Now, these ions are going to be accelerated around and then deflected by this magnet, and therefore you're going to have these different beams. It can be obviously more than 3 beams, but it separates the isotopes based on their different atomic masses. Now, the important thing for you to keep in mind is the fact that the less an ion is deflected, so for example this one right here, this one has a larger atomic mass than this one or this one. So think about it like a car going around a corner, right? There's going to be so much momentum for a heavier car that it's not going to be deflected as much as a lighter car, which is easier for it to kind of hug the curve, if that makes sense. In this direction, it's easier for it to be deflected. So this right here, this line right here, that's the heaviest one, while this one right here, that would be your lightest isotope. So what I'm going to do now is I'm going to use this concept that I just introduced about a mass spectrometer and use it to apply it to a problem. And so for this problem, it tells you that you have a mass spectrum of a sample, and you've got this information here. And first it asks you to calculate the relative atomic mass of chromium. Well, we know the relative abundance of each of these different isotopes of chromium, and so this is actually not new. I'm going to just find the weighted average for chromium. So I'm going to take the atomic mass of the first isotope, which is 50, and I'm going to multiply it by its percent abundance, which is 0.043. And then to that, I'm going to add the atomic mass of the next one times its percent abundance, which is 83.8%. Notice I'm making these into decimals. Then multiply that by the next atomic mass times its percent abundance. And then the next one times its percent abundance. Okay? And it tells me to round to 2 decimal places. And so what I end up getting is 52.06 AMU. Now this answer makes sense because the greatest abundance that I have for an isotope is the chromium 52. And so my answer should be as close to 52 as possible. And it is. It's 52.06. So that makes sense. Now, for new information, it asks me to sketch the spectrum that would be produced by this data. And so what I'm going to do, I'm going to put atomic masses. So I've got 50 here. Okay. I've got, let's say, for example, 52 right here. I've got 53. And then I've got 54. Okay? And so what I'm going to do is I'm just going to show peaks, and remember the peak needs to represent the relative abundance. So 4.3, I'm going to just make it like that tall, not tall at all. Okay? The 82% I'm going to make for the 52, that needs to be very tall. Okay? The 9.5 needs to be a little bit taller than the 4.5, like double the size, but still very low. And then the 2% needs to be even lower than that. Okay? And so that would be it. So this is the mass spectrum. It shows you that the smallest abundance would be the 54. It shows you the next smallest would be 50, then 53, and then 52. And so the x-axis represents the mass, while the peaks represent the relative abundance. So that is a mass spectrum. And you can actually use this in order to calculate the average atomic mass like we did right above. Okay? The next question tells you that it shows you the path of magnesium 25, and it's the magnesium ion with just a +1 charge. And so what it's asking you to do is then to sketch these 3 items. Now, this shows you, this information right here is what I've already explained with respect to the ionizer that ionizes the atoms, and then you have an accelerator that pushes it through. You've got the magnet, which causes the ions to be deflected. But what we're trying to see is, all right, we're going to have different deflections from this just magnesium 25. So if you look, it tells you have magnesium 24, 26, and then magnesium 25 with a 2+ charge. Okay, so I'm going to make this bigger actually, just so it's easier to see. Okay, I know that this is magnesium 25. Okay, with a +1 charge. Okay, and this lines up with this. So anything that's over here is going to be more massive than magnesium 25, and anything over here is going to have less mass than magnesium 25. And so it makes sense that I would put magnesium 26 hitting like right about here, because it's going to be deflected less than magnesium 25. And it also makes sense that I would put magnesium 24 here, because it's going to be deflected more than magnesium 25. Now here's the only issue, something that hasn't been brought up. Notice I have magnesium 24, 26, and then I also have magnesium 25, but with the 2+ charge. Now, the most important thing for a mass spectrometer is mass, but charge clearly must have something to do with it. So if you think about the fact that these are being deflected based on their charge, then it makes sense that the greater the charge, the more it's going to be deflected. And so I would draw magnesium 25 with the 2+ charge here, because it's going to be deflected more than magnesium with just a +1 charge, but less than magnesium 24.